Hello and welcome to Module 7. In Module 7 of Environmental Studies, we are going to be considering the environmental issues of air quality and climate change. So these topics are covered in Chapter 10. So unlike Module 6, we're just covering one chapter here, but it's broken down into two parts. So in the first part, which is where you're at now, we'll be introducing air pollution, looking at types of air pollution, sources of air pollution, and some of the consequences of anthropogenic air pollution and the efforts to address it. In the second part of Module 7 and Chapter 10, we'll be introducing climate change, and we'll focus on an analysis of both the causes and consequences of climate change, as well as looking at some of the global efforts to address climate change. So for this recording, let's jump right into a consideration of air pollution. So we are going to consider in this recording and in this portion of Chapter 10, the sources of global air pollution, I should say kind of the state of global air pollution, as well as the sources of air pollution. We'll consider the consequences of air pollution, both from an ecosystem perspective, but also from a human health perspective. And then we'll look at the efforts aimed at reducing air pollution, including legislation like the Clean Air Act, and other efforts to reduce air pollution. So by the end of this chapter in this lecture, you should be able to define air pollution and characterize its global impact. Again, identify the main types and sources of pollution, characterize the health, economic, social, and ecological consequences of air pollution. And we'll focus on some specific impacts like acid deposition. And you should also be able to, once introduced, explain the mandate of the Clean Air Act and how it's implemented. And again, reducing air pollution. And as usual, we'll go over a couple of summary or review questions at the end. So kind of the core message here, kind of the big picture theme for this issue in this chapter is that air quality issues are very much transboundary problems. They're worldwide global issues that have ecological consequences, but also have very serious health and economic consequences. And so we'll focus on those impacts as well. Air pollution does come from natural sources, but primarily from human sources. And so again, big picture here will be identifying what those human sources are and looking at strategies to reduce them. And policies play a really important role in restricting and managing issues related to air pollution. So the case study that your textbook highlights is one that hits close to home. So living in population dense Southern California, especially on the coastal side of our local mountains within the LA basin, we are no strangers to issues related to air pollution. And your textbook is highlighting this region in part because of the very high incidence of asthma among kids in Los Angeles County in particular. We're highlighting here a study that took place between 2003 and 2004. So for a 10-day stretch over that time period, 45 asthmatic kids from, again, smoggy Los Angeles County wore backpacks that contained these small monitors. And those monitors helped to sample the air around them as they just went about their daily lives, like went to school, went to the park, went to a friend's house, had dinner with their families, whatever it may be. They wore these backpacks all throughout the day. And those kind of personal air monitors are very accurate, more so than the measurements that are taken at local monitoring stations. So it allows for a much, data collection on a much finer scale. So those monitoring stations that collect data on weather and air quality can often be like many miles from where a particular individual lives or where a particular individual goes to work or goes to school. So those don't necessarily represent kind of your personal actual exposure. So the idea with this study that was conducted, by the way, by researchers at UC Irvine, just down the road from us. But with this approach, they were able to detect levels of harmful pollutants in the air, surrounding an individual child. The children that were selected for the experiment were ones that were all currently being treated for asthma. So they had that pre-existing condition, and the area in which they all lived had significant air pollution. And so the monitors that they wore were measuring the quantities of small particles of nitrogen dioxide. We'll talk more about these types of pollutants, but they're commonly present in vehicle emissions and are known to irritate lung tissue. And it's exposure to pollutants like that can trigger asthma, and the wheezing and coughing symptoms, the shortness of breath that comes along with it. In addition to wearing these monitors, 10 times throughout the day, the children would exhale into a special bag that assessed their breath for nitric oxide. That's a chemical indicator for airway inflammation. So it's essentially a proxy for asthma. When the 10 days were over, the researchers compared the types of pollutants that the kids were exposed to with their nitric oxide levels at similar points in the day, and used that data to essentially paint a picture of the types and amounts of pollutants that exacerbate asthma. So we'll come back to say more about that study as we kind of follow it through this chapter. Okay, so air pollution. We've talked about aquatic pollution and water pollution. And so we're extending some of the concepts we've already introduced, but looking specifically at atmospheric pollution. So by definition, air pollution refers to any material added to the atmosphere that harms living organisms, that can affect the climate or impact structures. All right, so these are including contaminants from natural sources, but also contaminants or pollution from human activities that, again, can cause those health or environmental problems. And the idea, as we started to highlight in the case study, is that, of course, researchers suspect and have since demonstrated that these pollutants may play a key role in a variety of health issues, but especially the relatively recently observed rise in asthma cases that began roughly around the 1990s and still continues today. So once again, I'm repeating myself, but we're going to come back to some of the ecological issues associated with air pollution. And of course, we're making the connection with climate change in this very chapter, but we are also going to highlight, the many serious health issues, respiratory infections, cardiovascular diseases, some cancers that are, correlated with air pollution. And of course, if we consider that globally, scientists have been aware of this link between outdoor air pollution and human illness for much longer than just since the 1990s. In the early 1900s, there were notable events in various countries throughout the world that were linked with mortality, with human mortality. If you ever watched The Crown on Netflix, they highlighted an event in one of the earlier seasons that was referred to as the Great Smog in London, England. That occurred in the early 1950s, I want to say like 1952. And that was linked with over 12,000 premature deaths. So again, asthma is a particular condition that's been increasing, and we've been tracking since the 1990s. The prevalence of childhood asthma had doubled between 1980 and the mid-1990s. So that set off a lot of early alarms and concerns. Although it's kind of leveled off in more recent years, those rates still are at historically high levels, with around 6 million children and 19 million adults diagnosed with asthma. So again, just one of the health effects of living in a polluted world. Okay, but as I've emphasized, this is a global issue. This is a global problem. So this diagram here is showing you data from the World Health Organization, who of course recognizes air pollution as a major threat to human health and identifies as many as 7 million premature deaths worldwide. And the vast majority of those kind of pollution associated deaths are occurring in lower or middle income countries. So we're seeing kind of per capita rates of that here, with the red and darker blue highlighting those regions where we see the highest levels. I imagine I circled Alaska here just as part of the United States, but I imagine most of those data that account for mortality associated with the United States is coming from the lower 48, less so in Alaska, certainly. But anyway, you might notice that both China and India account for roughly 50% of all air pollution deaths. These are data from 2017. And I would challenge you to consider some of the topics we've presented earlier in the semester, and consider, why air pollution deaths would be so high in those two particular countries. Okay, so let's get into some of the sources of air pollution. So when talking about water pollution, we introduced, give me 1 second here. My screen did not advance. Let me reshare here. Okay, so when talking about aquatic pollution, we introduced these two definitions. So I'm just going to remind you of them briefly here. But we were contrasting both point source and non-point source pollution. And that same idea applies to air pollution as well. So industrial pollution, for example, is usually released as point source pollution. So that's pollution that comes from an identifiable source. So this would be like a smokestack or some other outlet. This is a controlled burn of an agricultural field. Like we can see the source of pollution and identify it, which, as we know, makes it much easier to address that source. It's easier to monitor and it's easier to regulate point source pollution. Non-point source pollution is pollution that's dispersed from mobile sources, things like vehicles, lawnmowers, right? All the other ways that we add pollution to the atmosphere that can be difficult to target or identify as, again, a particular, one particular source. So harder to monitor, harder to regulate. Outdoor air pollution, we're going to differentiate a little bit further into the lecture between kind of issues related to indoor and outdoor air pollution. But right now we're talking primarily about outdoor air pollution. So outdoor air pollution includes chemicals and small particles in the atmosphere that, again, can be natural in origin. So wildfires, naturally occurring wildfires, volcanic eruptions, sandstorms, those all contribute to air pollution. So there's some baseline expectation for there to be chemicals and particles in our atmosphere as a result of those events. But a significant portion of outdoor air pollution, of course, comes from humans. And this would be those pollutants that are released from, again, factories and vehicles, typically associated with the combustion of fossil fuels, or from kind of burning biomass, burning garbage, burning crop waste like we saw here, burning wood, which a lot of people across the globe rely on as a biomass energy source. So of those Anthropogenic sources. So again, the human cause, will kind of set aside the natural causes for a moment. So of those anthropogenic sources, primary air pollutants are those that are released directly from mobile sources. So once again, those would be things like cars or from stationary sources. So those would be things like, power plants or factories. Okay. Secondary air pollutants form when primary air pollutants react with one another or with other chemicals in the air. All right. So some of those primary air pollutants, just based on their chemical or molecular composition, tend to react with other chemicals, and in doing so form different types of pollutants. An example of this is ground level ozone. So ground level ozone is an example of a secondary air pollutant, and its formation is the result of pollutants that are released during the burning of fossil fuels reacting with atmospheric oxygen in the presence of sunlight. Okay, so more specifically, nitrogen oxides, so things like NO and NO2, these are expressed just as NOx. That indicates that we're speaking about both of these nitrogen oxides. Those are the result of fossil fuel combustion. So that is, again, a primary air pollutant. But they can react with atmospheric oxygen in the presence of sunlight. And when they do, they become a very important component of smog, right? We're familiar with smog here in California. That word is amalgam of smoke and fog, right? This kind of hazy air pollution that will contain a variety of both primary and secondary pollutants, okay? We also consider, in terms of air pollution, the presence of particulate matter. So this is another serious form of air pollution. Particulate matter refers to particles or small kind of droplets that remain aloft in the air for extended periods of time. This is a common component in smoke and soot, and are released when just about anything is burned. Again, this is familiar to us in Southern California. So if you live in Orange County, during any one of the recent wildfires we've had in past years, you might be quite located relatively distantly from the fire, but you can wake up and your car is covered in ash or small little particles, right? Those are things that were carried as part of the carried or suspended within the air. Particulates, of course, have a variety of different issues associated with their presence in air pollution. They reduce visibility. Once again, we're familiar with that. It gets hazy when it's smoky. Part of that is because of the abundance of particulate matter. And this also has significant health impacts, right? So when there's high levels of particulate matter in the air, that can aggravate asthma. It causes issues for people with lung diseases. And there's other, other health issues that are impacted by that. Okay, so to just kind of briefly summarize what we've said so far with respect to outdoor air pollution. So we're looking here at the many sources of outdoor air pollution, and that would include, once again, some of the natural causes of air pollution, volcanic eruptions, naturally forming dust storms, naturally occurring forest or fires. And I keep putting naturally occurring in front of fire because, of course, human impacts have exacerbated the frequency and intensity of many fires. But fires have, of course, naturally always occurred. So those all contribute to primary pollutants into the atmosphere. Things like carbon dioxide, carbon monoxide, as well as those nitrous oxides that I mentioned earlier, nitrogen monoxide or dioxide. Additional inputs of those chemicals or pollutants that I just mentioned are attributed to stationary sources like industry, right? So factories that contribute these pollutants into the atmosphere, agriculture, as well as other mobile sources, right? Cars burning fossil fuels, mining, transporting materials around. In addition to the pollutants I've mentioned that form naturally, these stationary anthropogenic pollutants tend to include things like carbon monoxide as well. And of course, both have the potential to contribute high levels of particulate matter. And you can kind of reference this box right here for just a general understanding of kind of like the size of particles that we're considering here as part of the particulate matter. Of course, we're focusing on the troposphere, right? This is the lower layer of our atmosphere. This is the air that we breathe. And once again, those primary pollutants in our atmosphere can react with sun and oxygen to be transformed into different types of pollutants, ground level ozone, sulfuric acid, or nitric acid as examples of those, okay? Pollution can also move up. I'm focusing here on the troposphere, but pollution can move up into the stratosphere. And you may recall the stratosphere because we previously spoke about the ozone layer. So this is the region of the upper atmosphere here that contains the ozone layer, which we know protects living things from UV radiation. So certain air pollutions like CFCs can travel up into the stratosphere and destroy that protective ozone. I'm not addressing that here because we spoke about it previously in Module 5, but if you need a refresher on stratospheric ozone depletion, you might want to flip back to that. The last thing I'll say as far as the summary before moving on is, since I mentioned the ozone layer, this ground level ozone, which is a secondary pollutant. So don't confuse that with the stratospheric ozone depletion. So these are two different problems. They both relate to the same molecule. But ozone in the stratosphere is a good thing. It's supposed to be there, right? Again, it's what forms that protective layer. Ozone in the troposphere is the problem. That's why we differentiate and refer to this as ground level ozone. So breathing that in directly can cause damage to lung tissue. Again, it can trigger asthma attacks and cause other sorts of problems. Okay. I started the lecture by saying that air pollution is, very much a global problem. So going back to the case study that I introduced, those researchers were finding particles contained in the diesel exhaust that were attributed to being the most kind of the worst asthma culprits, right? And they found that particulate levels were higher in Riverside County, which is one of the two regions he tested. And they concluded that Riverside had more pollution because it was downwind of the main urban areas in Los Angeles. So with respect to that study, we can consider pollution in Riverside as a transboundary problem. So most of that smog and pollution is originating in the much more population dense county of Los Angeles, and it's traveling to Riverside County. And so there's impacts within Riverside County, even though it originated elsewhere. So that's a transboundary problem. And so when we're talking transboundary, it's, the scale can vary. It doesn't mean necessarily only different countries. So, different counties, different communities. Anytime an issue in one place affects a population in a different area, that is what we consider a transboundary problem. Of course, this can be the source of, conflicts between states or nations that are dealing with transboundary problems, especially in areas that don't have like the political strength or ability to kind of regulate air pollution that's generated outside of their borders. I mentioned Alaska, but even the most isolated regions on Earth are vulnerable to the effects of air pollution because circulation moves pollution around the globe. So agricultural pesticides, industrial chemicals have been found in remote regions of the Arctic and Antarctic, far away from where there are any farms or industries that would be producing such chemicals, okay? So, any sorts of solutions, approaches to addressing air pollution have to consider the transboundary nature of this problem. Okay, so we're going to shift now into looking more closely at some of the consequences of air pollution. So there are health, economic, social, as well as ecological consequences of air pollution. Health problems, structure damage, air pollution reduces visibility, contributes to stratospheric ozone depletion, as we just pointed out. And then, as we'll talk about in much more detail at the end of this chapter, relates to climate change. There are, we introduced this idea when talking about water quality and water pollution as well. But like with water pollution, air pollution tends to be worse in low-income areas, in areas where minorities make up a larger proportion of the population. So this is another environmental issue that raises concerns over environmental, justice and equity. Okay, so let's look at some of the consequences. We've referred to a few of these as well. This is a summary from, once again, the World Health Organization, who estimated that 7 million people die prematurely each year from exposure to air pollution. A lot of this is linked with respiratory ailments. The particulates from smog, from soot can damage respiratory tissue and increase susceptibility to infection. And we focused on asthma as an example, but generally speaking, children breathe in more air for their size than adults do. And their, developing tissue is more vulnerable. So these kind of lung air related issues tend to kind of disproportionately impact children. And that, of course, can start before birth, right? So maternal exposure to air pollution has been linked with mortality rates, premature births, and low birth rates as well. I'm focusing on some human health issues here, but this occurs within many animal species as well. So we've documented examples of different species of animals that suffer from respiratory distress in a way that is similar to humans. So essentially, all lung tissue, any organism with a lung or a gill for that matter is sensitive or vulnerable to air pollution. And actually, I shouldn't make that a defining statement because, plants suffer from air pollution too. They don't have lungs, but they have pores on their leaves that open to take in carbon dioxide for photosynthesis. And they can also absorb things like smog and ozone. And that exposure can reduce their photosynthetic efficiency and can impact healthy growth. So there's, wide-ranging impacts of air pollution on a variety of different types of organisms. One of the consequences of air pollution is acidification. We talked about the significance of ocean acidification. So we have some background understanding of this, but this is an issue in terrestrial systems as well. So acid deposition occurs when precipitation that contains sulfuric or nitric acid falls back onto land and water. So these dry particles can also essentially fall and become acidified once they mix with water in the form of precipitation. And that's what we refer to as acid rain. So acid rain is a type of acid deposition. So this can be snow, sleet, fog, and as I said a moment ago, even dry deposition. So this is an issue with secondary pollutants, right? It's produced when sulfur and nitrogen emission from burning fossil fuels reacts with oxygen and water in the atmosphere to form sulfuric or nitric acids. And acid deposition is quite harmful. pH is one of those factors that living organisms need to be able to regulate. And most organisms live within a pretty narrow range of pH. There's generally speaking, not a whole lot of tolerance kind of outside of this narrow range for most organisms. And so even a slight shift in pH can have really significant impacts. This is true of aquatic organisms, but it's true of land-based organisms as well. As soil becomes acidified, that negatively impacts the organisms that live in the soil as well as plant life. A lower pH generally affects the successful hatching development of fish and amphibians. It can interfere with the ability of certain egg-laying organisms, reptiles and birds, the development of their of their eggs. So there's a whole lot of ecological consequences that come along with this shift in soil chemistry that changes with acidification. There's an economic toll to this too. It's not just ecological. Those acids break down structures. So acid rain literally eats away at things like limestone and marble. They can etch glass. They can damage steel and concrete. And so in areas where we've seen significant acid deposition, there's a significant economic toll, causing, in some cases, billions of dollars of damage a year to buildings and monuments. Now, as I said earlier, there are certainly issues of environmental justice that are related to air pollution. I mentioned this briefly when talking about water quality issues. We highlighted the tragedy in Flint, Michigan. So exposure to air pollution very much has a societal link. Data supports that pattern that low income or minority areas have some of the worst air quality. And so environmental justice is, of course, a concept that access to a clean, healthy environment is a basic human right. And of course, that includes clean and healthy water, and it absolutely includes clean and healthy air. The sources of major pollution that we've pointed out, power plants, waste incinerators, those are often placed in areas where property values are lower, where residents have kind of less ability to fight for their rights, right? In higher income areas, there's usually more of an ability to get the type of legal support that's needed to oppose such things, right? So less money, areas where there's less access to education perhaps, or little or no voice in local environments. Many corporations are essentially taking advantage of that for deciding where to place power plants and incinerators and other factories that contribute to air pollution. And this is certainly true in the United States. This is a global issue, but it's a local issue as well. There was a study done in 2018 that looked at United States Census Bureau data and found that those living in poverty had a 35% greater chance of living near a source of particulate pollution than the overall population. And in some cases, even when socioeconomic status is accounted for, minority communities will face more exposure to pollution than average. So that is an example of environmental racism. So if you take the, again, socioeconomic factor out of it, and you find that minority communities are still facing more exposure, that's an issue related to environmental racism. And in fact, that same study that I'm referencing found that minorities had a 28% greater chance of living close to a pollution source. And Blacks in particular had a 54% chance of doing so. So this is an important thing to keep in mind as we consider the consequences to air pollution and the approaches to addressing air pollution, because the impacts are not felt equally. This is a global issue, but as we drill down, different groups are experiencing disproportionate impacts, and that's something very important to keep in mind. Okay, so once again, you have a nice summary diagram from your textbook summarizing these consequences. So air pollution, of course, is negatively impacting the natural environment and the species that live there. And so we'll be talking more about climate change. We've talked about ozone depletion, but this includes eutrophication, we've discussed earlier, reduced visibility, and then direct health impacts to plants and animals. But air pollution, as we know, and as we've reviewed, has a myriad of health impacts, including kind of immediate effects. You know, you may have experienced some of these following a wildfire in California, like a respiratory infection, a headache, throat, eye, or nose irritation. But there are also very significant long-term effects, including things like asthma, respiratory diseases, in some cases, neurological disorders, and some factors that impact, birth rates, premature births, low birth weight, so on and so forth. And then finally, the points that we were just making a moment ago that are some of the societal impacts of air pollution. And many of these are linked with environmental justice and racism. So low income and minority communities tend to be disproportionately affected. Health issues that come along with exposure to pollution over time can be linked with lost income due to missed work. So there's a cost to individuals and there's an overall cost to communities as well. Okay, so I kind of skipped ahead a little bit or skipped around, but I'll just say a little bit more about acid deposition before we move forward. So that secondary pollution, again, we mentioned lowers the pH of soil and water bodies, harms plants and animals that are exposed. And the CO2 emissions part we'll come back to. So anthropogenic CO2 emissions are increasing the acidity of the oceans with devastating consequences. And that is a topic that we already covered in module 6. Okay, so again, I kind of spoke ahead a little bit. Sorry, that review kind of got mixed in there. But once again, acid deposition is the precipitation that contains these secondary pollutants that cause, in some cases, dry particles to also fall and become acidified with water. So I'll kind of move ahead because I did talk about that already, but you do have another summary diagram in your textbook that nicely summarizes what we already discussed in terms of the impacts of both the causes and the impacts or consequences of acidification. Sulfur pollution, just to add one more specific example of that, sulfur pollution has been reduced significantly. And nitrogen pollution is on the decline. So we've had significant improvements in that respect. And this is showing the extent of nitrate deposition from 1988 to 2018, with the red being the most significant nitrate deposition. So there's a pretty dramatic decrease over those years, which is certainly notable. So in the United States, the overall kind of average pH of precipitation has increased due to acid deposition policies, meaning we have less acid rain. But ecosystems generally are slower to recover and rebound. So although that pH has changed to more sort of healthy levels, water and soil pH takes a longer time to kind of buffer those changes. And so we're moving in the right direction with respect to acid rain in the United States and with decreasing acid deposition. But again, some of our ecosystems tend to kind of lag behind and haven't quite recovered from that impact. So we're going to kind of wrap up this lecture by looking at some of the approaches to regulating and reducing air pollution. And I'm also going to talk a little bit about indoor pollution, since at this point we've been focusing mostly on outdoor pollution. So air pollution is not a recent issue, right, in the United States. At the turn of the 20th century, lots of cities were dealing with significant impacts associated with mining and coal soot. Lots of countries were, lots of cities around that time were kind of blackened with coal soot. I mentioned the smog event in London, England, but we were experiencing similar episodes here. Donora, Pennsylvania was kind of a classic example of that. So we were kind of early to detect these issues and early to enforce legislation to deal with it. So in the United States, pollution laws were passed as early as the 1960s, and they were kind of a start, but weren't enough. And kind of with the sort of birth of the environmental movement, the public wanted more, right? So there was a stronger support for legislation that called for more serious and more comprehensive air pollution laws. And that came together in the first ever Earth Day, which was in 1970, in April of 1970, very first Earth Day. And by December of that year, in response to that event, President Nixon signed into legislation the Clean Air Act, or CAA. And this was signed into law and this is what created the EPA, right? So we've talked about the Environmental Protection Agency quite a bit already, that same month. And this act has not remained unchanged. So since it was introduced in 1970, there have been significant major updates. So amendments to this occurred in 1977, 1990, and 2010. So the Clean Air Act is mandated to regulate the emissions of hazardous air pollutants, those that threaten public health and welfare. Those are the ones that are prioritized under the act. And when the EPA started regulating air pollution, the agency didn't really know kind of the extent to which different types of air pollution could affect health. And so this is an example of applying a principle we introduced very early on in the semester, the idea of a precautionary principle, right? So we're not totally sure yet exactly which chemicals are, causing health issues. This is back in the 1970s. So we're going to go ahead and regulate those that we suspect to be the most problematic. And these are what are known as criteria air pollutants. And so these are things like carbon monoxide, sulfur dioxide, and nitrogen oxides, as well as lead and ground level ozone. So of course, we know much more now about how those chemicals contribute to pollution and health issues. But at the time, these were listed, based on this precautionary principle. In addition, standards were set for particulate matter. It took another couple of decades before studies started to much more clearly establish the link between air pollution and health risks. Had we not invoked the precautionary principle and waited another couple of decades to regulate these chemicals, the extent of air pollution and the serious health problems associated with it in the United States would have been, all that more serious. So in addition to those criteria air pollutants, the EPA also recognizes 187 other hazardous air pollutants. So these are things that have some adverse effect on human health, even in really small doses. These can be things that are linked with certain cancers or developmental defects, things that are known to cause damage to our nervous systems or kind of other tissues. So one of those other hazardous air pollutants are what are called volatile organic compounds, or VOCs, as they're often referred to. So these are chemicals that readily evaporate and are released into the air as a gas. So a lot of, I should say, a variety of chemicals present a health hazard if inhaled, or if kind of sensitive tissues, such as like eyes, for example, are exposed. VOCs can be produced by natural sources, like plants produce volatile organic compounds. Wetlands are sources of volatile organic compounds. So like other air pollution we've talked about, there are natural sources, but the main source of VOCs is fossil fuel combustion. You may have also heard this in association with certain like household products. So paints, carpets, certain type of cleaning agents can also release VOCs, and that contributes to indoor air pollution, which we kind of consider as a separate category, and I'll talk a bit more about that. So, storing your paint outside in a garage, right? You don't leave an open can of paint in your house. So we've always had some awareness of the impact of these volatile organic compounds and handle them according to that. So once again, just another summary of what we just talked through as far as the 6 primary criteria air pollutants that are regulated by the EPA: carbon monoxide, sulfur dioxide, the nitrogen oxides, ground level ozone, particulate matter, and lead. And just for your reference, you can refer to what some of the common sources are for each of these air pollutants. And for most of them, you'll find both natural, or I should say for many of them, you'll find both natural and anthropogenic sources. Okay, before we completely wrap up, let's just say a little bit about indoor air pollution. This is a growing concern among a lot of public health scientists. Going back to the case study that we looked at, the researchers linking air pollution in LA and Riverside counties with asthma cases. There's a lot of other studies that over the years have shown the link between outdoor air quality, substantially impacting human health. But we breathe a lot of air indoors as well as outdoors. And so the impact of what we breathe within buildings and homes is significant. In fact, kind of people living in more affluent developed nations, in some cases, have some of the greatest exposure to unhealthy air indoors. So you may be living in a part of the world where the outdoor air quality is better, but you're doing activities inside that are contributing to potential air pollution sources. So cigarettes is like a primary example of that. We know about the very significant impacts that smoking cigarettes cause, but we also know about the very significant health problems linked with secondary smoke. So even if you're not a smoker, being exposed to that can cause, damage to mucous membranes, lung damage, can irritate and exacerbate issues associated with, eyes and noses, and can be linked with asthma and, of course, lung cancer. But there's a lot of items that we tend to keep around us that I mentioned a moment ago that release volatile organic compounds, and those are associated with health impacts as well. Outdoor pollutants can kind of find their way into buildings, can seep through the foundation of homes, accumulate in basements. Radon is an example of that. And then another really big source of indoor pollution is from cooking and heating. This is significant in developing countries where a lot of people will cook and heat with open fires indoors. And so the smoke and soot from burning wood, charcoal, in some cases dung or crop waste as a source of energy, then accumulates inside. So again, this is a practice that we're not as dependent on in the United States, but about half the world's households are cooking with solid fuels. I mentioned China and India as having some of the most, or some of the highest rates of deaths associated with air pollution. In India, around 20% of those deaths, which are, again, a substantial number, are linked with indoor air pollution that's associated with using wood or animal dung as cooking fuels. This is disproportionately higher in lower income areas where up to 40% of air pollution deaths are linked to household air pollutions. And I should say, this is not an issue of again, just the developing world and having indoor open fires. Some debate has resurfaced just this year over the use of gas stoves, but it's not a new discussion. Kind of the discussion over whether or not gas stoves should be banned in the United States is what kind of brought this issue, to kind of a boiling point. But scientists have long known that gas stoves emit pollutants that irritate human airways and can cause or exacerbate respiratory problems. Some of the earliest studies suggesting a link between, again, respiratory issues and gas stoves date back 20 or more years ago. Gas stoves burn natural gas. And the biggest concern for human health that results from that is nitrogen oxide. So that gas is produced when natural gas is burned at really high temperatures. And we've known for a long time that nitrogen dioxide has harmful effects on health. So once again, the EPA regulates that outdoors. So currently, the EPA regulates outdoor nitrogen dioxide emissions, setting standards for safe exposure limits, right? And that is based on our understanding that certain levels of nitrogen dioxide are bad for human health, right? But we don't have similar indoor exposure regulation. So again, that debate that sort of became politicized. It's unfortunate that it became politicized because we already do that for outdoor exposure. And, we have studies going back decades showing the harmful effects of nitrogen dioxide in gas cooking stoves. We understand those health impacts better over the last few years. There's been some key studies that have come out in the past 10 years that have suggested it is even more of a health risk than was previously thought. And that's part of what brought the more recent discussions to the forefront. So that might be an issue that you kind of picked up on playing out in the media. And it's something worth kind of taking a step back and looking at the history of it. So whether we're talking about gas stoves indoors, or whether we're talking about what happens in a very large part of the world of people cooking over open fires indoors, there are ways to address indoor air pollution again, separate from how we regulate outdoor air pollution. Of course, removing the sources, there have been some creative technologies that have been developed to provide alternatives to cooking with those more traditional open fires indoors. Installing chimneys to vent smoke, again, more efficient cook stoves, providing fuels that burn cleaner, things like kind of liquid petroleum gas. There's a lot of nonprofit organizations that have stepped up to deal with this problem, including the design and manufacturing of a very simple, relatively cheap solar cooker that allows people to cook without a fire. And then adequate ventilation. This, once again, applies to countries that are where you have a large proportion of individuals cooking over an open flame indoors, or in the United States where adequate ventilation should be prioritized for those homes that are cooking with indoor gas. Okay, so once again, I spoke ahead a little bit, but I think I made my point well about the cooking indoors and whether that's with wood or combustible fuels or natural gas in the United States. So I'll leave you to look at, once again, this summary diagram that shows some of the other sources of indoor pollution. And many of these are, point source types of pollution, so that we can identify the source and manage and regulate them appropriately. Okay, but finally, if we zoom back out again to look at regulating outdoor or reducing outdoor pollution, there's a variety of different approaches here. So some of those are kind of structural, as I just mentioned, to address indoor air pollution, solar ovens, better ventilation systems. But dealing with outdoor air pollution requires a much more integrated approach, especially because this is a transboundary problem. So regional, national, in some cases, even international approaches. Air pollution, as we said up front, often travels to areas that are not producing significant amounts of pollution themselves. So regulating air pollution is a challenge. In the US, our government has, of course, decided that regulation is necessary as part of reducing air pollution. The sort of typical approach that was developed in the 1970s is what's referred to as a command and control regulation. So command and control regulation is a type of legislative regulation that sets national limits on how much pollution can be released into the environment and imposes fines against violators who release more than is allowed. Fines, or in some cases, criminal charges. So in the United States, the Clean Air Act sets a maximum amount of a pollutant that can be released or that can be present in the ambient air. And as a result, the United States we've seen major reductions in common air pollutants like lead and sulfur. In fact, I should have said this earlier, but since the Clean Air Act was passed in 1970, US air pollution has been cut by 70%, even though our nation's economy has doubled over that time. So that is a significant accomplishment. And there's a variety of ways that industries, power plants, factories will address these Clean Air Act mandated performance standards through, again, command and control regulation. There's a lot of end of pipe solutions and technologies, things like filters, scrubbers, catalytic converters that trap pollutants before they're released. We now use cleaner fuels, right? Natural gas instead of coal, or energy sources that don't release pollution, solar, wind, nuclear, hydroelectric. hydroelectric. So investment in those energy sources has contributed to the reduction in air pollution. There's other economic incentives that are either kind of positive or negative. So green taxes, we've mentioned these before, but a green tax is any tax, a fee, of course, paid to the government that's assessed on environmentally undesirable activities. So there's an extra tax, for example, on gas guzzling vehicles. So vehicles that have very low mile per gallon ratings are assessed an extra tax. So you have to basically pay more for the right to burn extra fossil fuels. Tax credits are a sort of positive economic incentive. So tax credits are reductions in the tax that you pay in exchange for some desirable action. So this is a way that the government basically incentivizes activities that would reduce air pollution. So in contrast to a gas guzzling vehicle, if you have a very high efficiency vehicle, a hybrid or electric vehicle, there's some tax credits that come along with the purchase of those types of vehicles. We've also talked about the use of subsidies, and remember, a few people asked about this after the last exam. Subsidies can support sustainable activities or unsustainable activities. It's a matter of what the government is investing in. So there are a lot of unsustainable agricultural practices that are subsidized by the government. So subsidies are any financial assistance given by the government to promote desired activities. Whether or not those desired activities are environmentally friendly is another question. In this case, to reduce air pollution, subsidies are often provided to, for installing solar panels, for example. That would be a subsidy that is promoting a sustainable alternative in this case and helping to reduce air pollution. And then finally, another concept that we've talked about previously, cap and trade programs. So this is a method that combines kind of the performance standards of the command and control regulation with economic incentives. This is also sometimes referred to as permit trading. So a regulatory agency sets an upper limit on emissions, right? And gives or sells permits to polluting industries. And then each of those permits allows whoever holds that permit to release a certain amount of a given pollutant. So if you stay within that limit, on a given year, you use up all your permits and then you're reissued more permits. Users that reduce their pollution emissions, so if you use fewer permits than needed, can sell their remaining allocation to other industries or companies that exceeded their limit. So over time, the cap is slowly lowered, right? The limit is slowly lowered, but it allows, it provides incentive for individual organizations to reduce their emissions, and then it allows a sort of a sharing type approach to meeting that overall cap. This is a very successful method for reducing sulfur pollution in particular. So this was instituted with coal-fired power plants in the US in the 1990s. And we'll see how cap and trade programs are used for other aspects of climate change toward the end of this chapter. One of the downsides to a program like that is that pollution can become concentrated in areas where kind of individual industries are able to buy additional permits rather than reduce emissions. So even though we will stay under the cap as a country, it can mean that there's still hotspots of emissions and for companies that can afford it. Okay, so once again, you've got a nice summary diagram of these different approaches to dealing with outdoor air pollution, and a lot of that is technological, and there's been huge technological advances, things like smokestack scrubbers, filters, catalytic converters that help trap contaminants and prevent the release of those into the air. But we rely heavily on a variety of different policy approaches that I just reviewed: subsidies, green taxes, market-driven financial incentives like the cap and trade program, and in some cases, penalties. Okay, so in summary, air quality issues span the globe. They have serious health consequences, serious ecological consequences, and often very serious economic consequences as well. We highlighted the case study of asthma, and that of course has a serious health impact, but a serious economic toll also. Most of the air pollution is caused by human activities. We identified natural sources of air pollution, but those are not contributing to the overwhelming amount of particulate matter and pollutants that we find in our atmosphere. There's been a lot of changes with the Clean Air Act over recent years, and actually this is referring more specifically to the Trump administration. So under the Trump administration, a lot of environmental laws were kind of under attack from the perspective of the regulation seeming intrusive. The bottom line, as I pointed out earlier, is that our air is much cleaner today than it was in the 1960s, even with a larger population and with more industry than we had in the 1960s. So that speaks to the fact that regulations have been effective. But the improvements that I mentioned, the technological changes, those are all costly to industry. And those costs can cut into profits and are then often passed down to consumers. So lots of individuals and groups still oppose these policies and impose the implementation of the various parts of the Clean Air Act. And they would charge that kind of the restrictions are excessive, or that the government's going too far to regulate emissions. All right. And so again, this current administration here is an outdated reference, but it's referring to in 2017, when newly elected President Trump ordered a reevaluation of the Clean Air Act and of the EPA's Clean Power Plan. And in 2019, the EPA replaced the Clean Power Plan with a new rule that's referred to as the Affordable Clean Energy Rule. According to research that's been published, that Affordable Clean Energy Rule allows most coal-fired power plants to stay online longer than the Clean Power Plant would have permitted. And so it's expected to result in little further decrease in carbon dioxide emissions, essentially bringing to an end the decline that started happening in 2005. Your book goes into a little bit more detail about that, but I wanted to mention this here because the important legislation and the government bodies that deal with the kind of enforcement of environmental laws are still subject to change as political administrations, or excuse me, as government administration shifts. Okay, so we'll wrap up there, and you have some study questions to help review the key concepts presented in this lecture. You've got your study guide and vocabulary terms to review as well. And we will finish up Module 7 and Chapter 10 by covering or by introducing global climate change, causes, consequences, and solutions.